And what I was trying to graph there a while ago is, so A has this very precise value of being equal to B sine A, or it has the necessity to be, so the A values that create a single triangle. So here you have the two triangles. Here you have one, here you have one, and here you have none. Okay, so these are a range of sizes that the second side can be. So we go A, B, A. So he determines the nature of the set of solutions. Okay, this is a straightforward question. There's only one answer. We are find length DE, find the thing opposite F, which is opposite 62. So find this length, correct to 1 decimal place. Okay. No, DF. Okay, let's throw that away. I don't need to see it. I could just get into this. And by the way, you could also just take the approach, I don't want to know anything what you just told me. We know there's a unique... What am I looking for? Find DE. Find the third side. And this third side length will there only be one possibility. Okay. Starting off, it's looking quite interesting. Because I have a pair. And so I'm going to have to find that angle first, whether I like it or not. Okay, so I'm going to find angle D, and I got the sine of D over 8 is equal to the sine of 62 over 11. So D is equal to inverse sine of 8 sine of 62. Now this is the one that could have a complementary answer, but we won't allow it. We're pretty sure we'll try, we'll pretend, and we'll see that it's nonsense. Okay, so we go inverse sine fraction bar 8, and we're going to do our sanity check here. Is angle D opposite 8? Yes it is. And is 62 opposite 11? Yes it is. Everything is fine. 8 sine, what am I getting? 62 over 11. Okay, that's 40 odd degrees. Let's knock that off there, go back to normal mode. 39.95 degrees. Now when I say R, it's a tentative R. And we put 180, roll forward and put 180 minus this. And I know this is going to be nonsense. So when I get 140 degrees, it's way too big because 140 and 62 is too big. So I hope you know that there's two ways of seeing what's wrong and why there can only be one answer. So we knew that angle is 39.95. Now I have a feeling that's not actually the answer, that's just on our way to the answer. Because remember, we're looking for this length. So we're just going to use 39.95 up there. It's going to be a little bit messy for a second. I'm going to... Well, now another thing I'm really annoyed with is that answer is no good to me anymore. So I'm going to have to come back in here and edit away the 180 minus. Okay, to come back to that exact answer. And I want to subtract, so I'll roll forward there and I'll go 180 minus 62 minus that. Okay, giving me 78 degrees here. Okay, now there probably were other ways as well of doing this. But I'm happy enough with what we have so far. So 78. And there is an F on my calculator, so I'll store that to F. Shift store F. Yeah. Okay. So strive for clarity yourself, and if you need to slow down and go to the end of the booklet, get extra paper if you need to work on top of a diagram you already have. Don't compromise. Okay, so we're looking for F. So we have a few choices. Let's go F over the sine of its opposite angle is equal to 8 over the sine of 39.95. We can calculate that directly because we can cross multiply, we don't have to write it down. Okay, so F equals fraction bar 8 sine 78, and ring it out in your head what it sounds like so you're keying it into your calculator correctly, all over the sine of 39.95. And by very virtue of ringing it out like that, you know where the decimal place is. Ooh, no, I forgot to put in my sine. Sine of 39.95, and that brings in the problem. And look at all those decimal places, and you have to click to get out to your closing argument bracket. Yucky. Okay, so F equals 12.18. It's the only answer. Correct to one decimal place, 12.2. God, I told you I'd do it quickly. Is that in centimeters? Yes, it is. Okay, the area is fine, MP correct to one decimal place. Okay, so just let's model away here and see what we're talking about. So we don't really know the picture. We've got data. Let's draw a picture, albeit not particularly to scale or anything. Just get a generic triangle drawn. NP is 8 centimeters. The angle at N is 55 degrees. If the area, now look, I want to show you how well I would depict that. So once I see area, I might want to give myself a lot more space for the triangle, and not be so greedy using up the internal space, because I want to write 29.49, and the way we depict area in maths is to put square brackets. Okay, yes, I should have put the units as well. So let's continue on here with the data I've just had. 8 goes here, centimeters. The angle at N is 55 degrees. So you just have to allow more space there for that. And there are my 3 pieces of data entered onto my thing. Find MP correct to one decimal place. Well, what the hell is MP? MP is N. So we're going to find N. Are there going to be 1 or 2 answers? Well, that's an interesting question. Let's see. So let's use the formula that half... No. Great question. I can drop a perpendicular that way onto this. No. Good question, guys. Very good question. Okay, let's find P first and then N. I don't see a better way. So let's get P. Well, there is maybe a better way. Let's put this length on the positive x axis where we don't know how far it goes. Let's put the 8 shooting up there at 55 degrees. So I could have gone along, I could have said here half, and let me put the 2 at the bottom, half 8 by P by the sine of 55 degrees, that's little p, equals the area 29.49, and I'd have solved for P and then gone off. But I was a little concerned that just seems like a little bit inefficient, and we're striving for efficiency here. So let's see how we're getting on here. I have an unknown length here, That's that. And I have 8 going up at 55 degrees. That help at all? Well, base by perpendicular height. But what perpendicular height? What am I talking about? Half the base by the perpendicular height. But this is the base. So the perpendicular height will be going off here at right angles. And I don't know how far that goes. So we go up, and that's great. It's great to just problem solve. It's great to think outside the box and assimilate your new knowledge into your old knowledge. That's what it's all about. It's all about connections. So what I'm doing here, so please slow the video down, pause, and you go along my journey, and you'll end up knowing your maths very, very well. Okay, dead ends are okay. And maybe it wasn't a dead end. Maybe I almost got some other way of doing it where I could get it directly. But look, I have this formula. It's correct. I want to isolate P. I can do that very easily. I can bring up the 2 times 29.49, and I can drop down the 8 times the sine of 55 degrees. So that gives me this length P. And of course, as you say, getting any new information is moving us towards the solution, even if it's not what they asked us to get. So we're into a fraction bar. We have double a length multiplied by 29.49. Downstairs 8 times the sine of 55. Okay, and whoa, it's pretty much they wanted it to be 9, and they made it as all the numbers. That's why they used 29.49. So we'll call that 9. So we have a new picture now. We can redraw it if we want. 9, 55 degrees, 8. And we probably dispense now with the information for that, and we're looking for this. Well, now that looks like a cosine rule, right? Because that's our angle sandwich. That's our included angle situation, where we know the lengths of the arms, or we know the lengths of the adjacent sides in the triangle, I should say. We should use the language of triangles, not the language of angle, because the language of angle have raised to go on forever. So let's say it again. When you have a triangle with both adjacent sides known to the included angle, then you can get the opposite side real easy. So that opposite side is equal to the square root of 9 squared plus 8 squared minus 2 times 8 times 9. By the way, don't do the calculations that you're about to do later here. Let's just write this the way it is. Over times the cosine of 55 degrees. Always bring this bar out and down like that to show that it's what it's doing. Okay, pick up your calculator, and that's not ambiguous. There's only one possible answer. Same time, that was not ambiguous. Okay. So look, that's the answer that's in my thing at the moment. So just to be pig-ironed about it, I'm going to say answer squared. But you do that at your Pearl. You be very, very careful with that. And you're perfectly okay to write 9 squared there now. Plus 8 squared minus 9/16. I'm pretty certain I got that one, guys. Okay, times the cos of 55 equals 7.899. So it's pretty much, and if they wanted to correct to one decimal place, so that's 7.9. So length n MP. So just write MP equals 7.9. And in your level here, you can just write, unless you write the word exact, we'll assume it's not exact. We'll assume it's written to one decimal place. If it isn't, if it turned out to be exactly true, you'd write exact. You should. And again, you don't even have to do that, because it's school maths. It's a good habit though. Okay, we're pushing on. You can certainly see how long it takes to do your homework if you're doing them all. But that's why these videos are there for you to look over, and maybe just once you're confident you're able to do them. That was an interesting question, question 5. Okay. So I'll just make a list maybe of what's challenging. And I could reduce maybe the amount of easier questions for you, and we could make that a habit in general. I'll put stars in my book for that. Question 5. it was interesting to say the least. Okay, so question 6. What do you do first? You do that first. What do you do next? You do that you know xz is 6.5. You do yz is 8. You do the angle at y is 40. Show that there are 2 possible values for xy. So we'll do it in a few ways. We'll make that the unknown length. We'll make the 40 degree go here. So this is how we always want to go, like this. We make the 8 go here. We'll work out that length. And they asked us to find them. If they didn't ask us to find them, we'd be finished in a few seconds. So this is going to be 8 times the sine of 40 degrees. Okay, so this is equal to 5.14. We're being given a length xz is 6.5. So after the 8, so this is allowed to be 6.5, and there you go. You see the 6.5 is in this sandwich here between 5.14 and 8, so he can go both ways. Okay. Now when it comes to actually calculating it, show that there are 2 possible. Oh, sorry, there are 2 possible values for some length. What's that? Yes, and what that is, there's that length and there's this length. So if there's 2 possible values for the angle, then there's 2 possible values for the length. Okay, cool. So where is this? Well, you want to say what it's the letter that isn't x and y is z. So we're going to get, we're going to get angle z. We're going to get 2 possible values for it. And it's the sine rule in this case, because it's the sine rule that contains the ambiguity. No, I can't do that.